Right, this is podcast number 4, just picking up where I left off. Right? So one thing is you cannot deal with a quotient. So you do need to simplify the quotient. By dividing all terms in the numerator by the x squared. Okay, so in other words, you need to rewrite as a sum or difference. Okay. So we have the integral. So if I divide x to the 4th by x squared, this is going to be x squared minus, and 8x cubed. Actually, maybe I'll even write it the long way, just to make sure there's no questions. All right, so x to the 4th divided by x squared minus 8x cubed divided by x squared. So just splitting this into 2 fractions, in other words. Okay? And that's dx is my variable of integration there. So this reduces to x squared minus 8x. And so we can take the integral of x squared dx minus the integral of 8x dx. And we can even factor out the 8 if we'd like. And so the integral for x squared dx would be, we'd increase the exponent by 1 and divide by that same value. Increase the exponent by 1 and divide by that same value plus our constant of integration. So that's going to be x cubed divided by 3 minus 4x squared plus c. That would be the function who has that as its derivative. Let's double check that. This is one that's worthy of double checking. All right, so we'll take the derivative of x cubed divided by 3 minus 4x squared plus our constant. So the derivative of the derivative here of x cubed over 3, the 3 will move in front, would be 3x squared divided by 3 minus, so 2 times 4x, and then that would be to the first power. Boy, that 4 looks bizarre. And then the derivative of the constant would just be 0. Okay. And so we would have x squared minus 8x as our function there. And that is actually the same as, so is that the same as our answer there? X to the 4th minus 8x cubed over x squared. Well, yes, it is, because that's actually what we rewrote, right? X squared minus 8x. That's the same as this here, right? So we can reduce, right? Because we could factor out that x squared, and we'd have x squared minus 8x divided by x squared, and look, there it is. Okay, so there you can see that our answer checks out. I'm just doing those on a couple just to show you, yep, it's correct. All right, so first thing we need to do here is rewrite with rational exponents. All right, so we have the integral of 8x to the 1/3. And actually, I'm going to split it up as well. I'm I'm just going to split it into individual terms. I like to deal with one term at a time. I don't like to look at everything at the same time. So minus, this would be 6x to the negative 1/2 dx. I can factor out the 8. So I've got x to the 1/3 dx minus 6 times the integral of x to the negative 1/2 dx. And then we can integrate. So that would be 8, and it would be the power rule. Oops, that's a U. There we go. My hand's getting tired. I did all of these podcasts in one shot. All right, so this would be 8x to the 1/3 plus 3/3 divided by 1/3 plus 3/3 minus 6x to the negative 1/2 plus 2/2, and then divided by negative 1/2 plus 2/2 plus c. So that would be 8x to the 4/3 divided by 4/3 minus 6x to the 1/2 divided by 1/2. And we know that dividing by a fraction is the same as multiplying by the reciprocal. So that would be 3/4 times 8x to the 4/3 minus 2 times 6x to the 1/2 plus c. And so that would be 6x to the 4/3 minus 12x to the 1/2 plus c. Or if you want, you can make that a square root, but it's fine like that. And if you take the derivative, you will get the answer above as your derivative. So if you take the derivative of our function here, 6x to the 4/3 minus 12x to the 1/2 plus c, you take that derivative of that function, you will get the integral as the answer. Okay. Right, so this one is a power rule. It's a nice easy one actually, but I need a color I can write with on this, like yellow. All right, so we're taking, and if you like, I would rewrite this as a negative exponent rather than as a rational term. Okay. So this would be the integral of 12z to the negative 5 dz. You can factor out the constant multiple, so that's now z to the negative 5 dz, and it would be the power rule. So it would be 12 times z to the negative 5 plus 1 divided by negative 5 plus 1 plus c, which is 12z to the negative 4 divided by negative 4. So final answer would be negative 3 over z to the 4th plus c. We should simplify the negative exponent at the end there. Okay. We take the derivative of that, and we will indeed have 12 over z to the 5th as our derivative. Okay. Right, so here, another nice easy one. We can split this up. So we have the integral of 3z squared dz minus the integral of 4z dz plus the integral of 5 dz. Oops, I started to write an x. dz. Right, now I can factor out the constant multiple. So 3 times the integral of 3 squared dz minus 4 times the integral of z dz plus 5 times the integral of dz. All right, so power rule all the way through. So this would be 3z 2 plus 1 divided by 2 plus 1 minus, f equals 4z 1 plus 1 divided by 1 plus 1 plus 5z plus c. And so this is going to be, well, that's 3 and that's 3. So that's going to cancel out. So this would be z cubed minus well, this is 2, and 4 divided by 2 is going to give us 2z squared plus 5z plus c. And if we take the derivative, it would be 3z squared. Derivative of negative 2z squared would be negative 4z, which is what we have there, and the derivative of 5z is 5. And the derivative constant is 0. Okay, so not too bad. I actually am going to do one little thing. Sometimes the 2's and the z's look an awful lot alike. So let's do that, and then there's no confusion. Oops, well, there's no confusion except that last one there, where I can't seem to write a z, where I can't seem to write a line in. There we go. That way it doesn't look like 52, it's 5z. Here we have a quotient. You must split the quotients. Now, trying not to get ahead of myself, there are other ways of taking the integral that will be different, that won't involve splitting quotients, but those require us to be a lot farther along, and it's a very different function. Okay? So until we get to that point that we look at other methods of integrating, and that will be a little while, just note that when you've got a quotient for right now, you've got to split that quotient. Okay? And I'm also going to rewrite the radical there. Let me write that a little clearer. So we're going to rewrite that radical into rational exponents. So now this would be x squared plus 1, the integral of x squared plus 1. Oh, I don't know what happened to the dx there. It got lost. Divided by x to the 1/2 dx. Right, so we would have the integral of x squared divided by x to the 1/2 plus dx plus the integral of 1 over x to the 1/2 dx. So that's the integral of x to the 3/2 plus the integral of x to the negative 1/2. And now we can just take the integral of that. Okay, so on these more complicated quotients there, we're going to split it up first. And so it has to be that we have only one term in the denominator, otherwise we're going to have a problem. We're going to split that up first into so that we have just sums and differences. And then now we can use our power rule. So this is going to be x to the 3/2 plus 2/2 divided by 3/2 plus 2/2 plus x to the negative 1/2 plus 2/2 divided by negative 1/2 plus 2/2, which is x to the, let me just fix my f there, 5/2. I keep forgetting, it won't automatically give me yellow. I have a green pen in my hand, so it'll automatically write in green. So it would be x to the 5/2 divided by 5/2 plus, oops, I didn't put a constant over here, plus x to the 1/2 divided by 1/2 plus c. So our integral is going to be 2/5 x to the 5/2 plus 2 times x to the 1/2 plus c. So there is our integral. That's the function who has this as its derivative, because that is the exact same thing as the step below it. All right, so here we have a product. You got to multiply. So we can change it to sums and differences. Okay, so we have the integral. We multiply that, we have x squared. So that's going to be minus 2x. Actually, I'm going to have no like terms here, so I'll just multiply each one of them. So we have x squared times x is usually x cubed. So we have x cubed minus, actually let's do plus 3x squared. I'll multiply those outer terms first, and then minus 2x, and then minus 6. Okay? So all I've done is I've multiplied the x squared minus 2 times the x plus 3. No like terms here. And then now we'll just take the integral of each of our terms. So x cubed dx plus the integral of 3x squared dx minus the integral of 2x dx, and then minus the integral of 6 dx. Okay. So the integral of x cubed is going to be x to the 3 plus 1 divided by 3 plus 1 plus, I didn't factor out the 3 on this one. I think I'll just write it, factor it out as I take the integral of the x squared part, just to save myself a step. So plus 3 times x to the 2 plus 1 divided by 2 plus 1 minus 2x to the 1 plus 1 divided by 1 plus 1 minus 6x plus c. And then let's simplify that. So now I've got x to the 4th divided by 4 plus 3x cubed divided by 3 minus 2x squared divided by 2 minus 6x plus c. And now that's going to simplify to x to the 4th divided by 4 plus x cubed minus x squared minus 6x plus c. And of course, if we take the derivative of each of these, we're going to get right back to those terms right there. Okay? Because the derivative of our function is the function that we're integrating. Okay? So I hope this is making sense to you. Really, most of the time, we've just been undoing the power rule. And so for the power rule, we divided by our x, or we multiplied by our exponent, and we added one, subtracted one to the exponent. So now we're just going the other way. So instead of multiplying by that exponent, we're dividing by the exponent. And instead of decreasing our exponent by 1, we're increasing our exponent by 1. All we've been doing for the most part has been undoing the power rule. And the only other thing we learned is e to the x and the natural log. So when we have 1 over x, its integral is going to be natural log of x. So here, we do need to simplify first. Because we have no other way to integrate that square there. That's a problem. But we could easily rewrite x minus 1 squared into x minus 1 times x minus 1. And the product of those two is just x squared minus 2x plus 1. And now we can take the integral of the x squared part and the integral of the 2x and, oops, excuse me, I forgot to write the dx's next to it. My variable of integration. Minus the integral of 2x dx plus the integral of 1 dx. And so we would have as our integral, and that's our original function, plus or minus a constant, would be x to the 2 plus 1 divided by 2 plus 1 minus 2x to the 1 plus 1 divided by 1 plus 1, and then plus x, and then plus our constant of integration. So our answer here is x cubed divided by 3 minus this is just going to be a 2, and these two will cancel. So it's just going to be minus x squared plus x plus c. There's our antiderivative. And so here, same thing, we have to simplify first. In both cases, we're just multiplying. So I need to rewrite that square root of x first of all, so that I have 1 plus 10x times x to the 1/2 dx. So that would give me the integral of x to the 1/2 plus 10x times x to the 1/2 would be 10x to the 3/2 dx. And so we can just take the integral of each one of those. So x to the 1/2 dx plus the integral of 10x to the 3/2 dx. And so we would increase by 1, oops, sorry, I meant to put a 2 there, and divide by the same thing. And so that's going to be a 3/2, right? Actually, I'm going to kind of just shorten up my steps just a little bit here. So I hope I don't lose anybody. So if I add 1 to 1/2, I'm going to have 3/2. And dividing by 3/2 is the same as multiplying by 2/3. So the integral of x to the 1/2 is going to give us 2/3 x to the 3/2 plus 10 times, actually I'll write the value first. So we have x to the 3/2 plus 1 would be x to the 5/2. Dividing by 5/2 is the same as multiplying by 2/5. But there's already a 10 there. And then plus our constant of integration. So now we can simplify that. So our function will be 2/3 x to the 3/2 plus 4x to the 5/2 plus c. So all I did is I multiplied 2/5 times 10, which is 20/5, which is 4. Okay. And so that's our integral. That's the function who has this factored form here as its derivative. Okay. We've just rewrote it so that we can integrate it, because we can't work it in its present format. We can't work it as a product, but we can easily change that product to a sum and difference by distributing that x to the 1/2. Okay. So same thing here. We got to simplify first, and so we're going to multiply. Before we can integrate. Right, so this, we multiply, this is just x squared minus 2x plus 4x would be plus 2x, and negative 2 times 4 would be a negative 8. And now that's pretty easy to integrate. We have x squared dx plus the integral of 2x dx minus the integral of 8 dx. Right, so the integral of x squared dx, we're going to increase by 1 and divide by the same thing. So it's going to be x cubed divided by 3 plus 2x squared divided by 2 minus 8x plus c, our constant of integration, and then we'll just reduce. So our integral is going to be x cubed divided by 3 plus x squared minus 8x plus c. And like I've said before, if you take the derivative, you're going to get right back to this function. If you want to get back to this function, you'll also have to factor. So if you take the derivative and then you factor it, you'll get back to what we started with. This one we have to simplify. We have two terms, we can't just divide. However, if we factor first, we'll find that we could reduce. Then we can integrate, because we're going to have something much simpler. Right? So x squared minus 1 factored is x plus 1 times x minus 1. Oops. There we go. All over x plus 1. The two x plus 1's cancel. So now you've got the integral of x minus 1 dx. And so now you could take the integral of x minus the integral of 1. And so our function, our integral, is going to be x to the, we got to increase the exponent by 1, so then it's going to be 2. And we got to divide by the same thing. Divided by 2 minus, still a power rule, that's technically x to the 0, so that's going to be now x to the first, and no point dividing by 1. And then plus c. Okay. There is a little caveat on this one because of what it originally was written as. X cannot be -1. So there is a little extra on this one. I can't have x be equaling to -1 because that would make it undefined because this was a rational function. Okay. So in case you have to reduce, just make sure you don't use anything that in the original function, the original derivative here would have caused it to be undefined. That's a little bit advanced though, but I think you could figure out that x can't be -1 because you just canceled out the x plus 1. The trig integrals. I'm going to stop here and then I'll go over these ones. Okay? All right. Last podcast for today. Period.